Good evening, everybody. I'm James of S&T Geotronics LLC, also known as KM4YWT in other circles. And if you happen to be in one of them other circles and are expecting one of these, they're on the way. I'll get stamps tomorrow on the way home from work. Anyways, tonight we're going to be discussing continuing the series on programming the Open DSKY. Alrighty. Tonight, we're going to play around with our brand new, state-of-the-art, never been done before, S&T Geotronics LLC DSKY Replica version 1.0 Echo. Echo's never really been used before. It's just fresh assembly, and it may not work correctly, but we'll see. Anyhow, we left off last time with this bit of code right here. This little bit of code, which is a demonstration to make sure that these maxims are working. Anyways, I said we're going to work towards getting some useful information on the display. And tonight we're going to have a small installment. Yes, another small installment. Past couple days have been rough. I'm exhausted. Anyways, we're going to have a small installment on how to get useful information on this. And basically, we have to include this library, LED Control H. That's what we're working with. Anyways, we're going to start a brand new, never been seen before file, new. Where'd he go? Where did he go? Is he under me? Under me. Imagine that. Likes to hide stuff under me. Alright, and here we go. Brand new, never been seen before file. Oh, sketch 22 February Charlie. Uh-oh. He's giving it away. I've done this before. Alrighty then. So we need our include LED control.h, and I'm going to grab the include LED control.h, Control C, and I'm going to bring him over here and give myself some lines above the setup, which is an irritating thing about that they put void setup in there with no lines above it, and a Control V, and there's our line that says include LED control H. And then I'm going to get this line that's a thingamajig that tells the LED control to be LC and gives them as parameters for setup. Control V. And you'll see here the LED control, LC equals LED control 12, 10, 11, and 4. 12 and 10 and 11 are the pins that are used on the Arduino, and 4 is the number of chips that we're going to control. And I guess I'll show you really quick on the schematic where the 12, 10, and 11 are. Wake up, CAD program, file. Let's try this one. There it is on the CAD program. As it was drawn, there we have the Arduino drawn on the CAD program, and you can see pin 12, 11, and 10 are hooked up, and we can see that pin 12 goes right up here to the first maxim to data in, and this is actually shifting the data out of pin 12 and right into that maxim through his data in. And basically what happens in the maxim, since it's a shift register, it knows how many bits it has to shift to fill the maxim up. And by knowing how many maxims there are, it knows every time how many bits of information it has to write to the array. So it's going to write for all 4 maxims every time. And what comes in here gets shifted right out there and comes down here and goes to the digital in on this maxim. So basically he's going to shift. Each maxim takes 8 bytes of data, so it holds 64 bits. So he's going to push out 64, 128, and basically for all four of them he's going to shift out 256 bits of information. Pretty neat. Anyhow, and the 10 and 11 are hooked to the load in the clock. And it's actually 11 here that is actually hooked to the clock, and the other one is the load. These are just timing functions. The load turns the thing on and off in the clock. When the load actually blanks it, well, it's actually writing the digits to it, and the clock just tells it the synchronization for sending the bits. Played around with once that didn't have the load hooked up, and you could actually see the digits being written to it real briefly. Anyway, so that's the explanation of the schematic. We could spend all day talking about the schematic and how it works. Oh, the other important thing on the schematic before we go is this resistor right here. Each one of them has one. And this resistor, for our kits, we include a 10K. But if it's not bright enough, you can change that value, or if it's too bright, you can change that value, and it'll control the maximum further than the set intensity function in the setup. Boink. All right, let's get our brand new program back. And let's look back at this thing here. This thing here, we have all these lines here that say LC shutdown, LC shutdown, LC shutdown. And we do it 4 times. And then we set the intensity 4 times. And then we clear the display 4 times. Once for each of the Maxim chips. Anyways, so I'm really lazy and I don't like writing all these lines of code. And I'm not. I'm simply not. I don't type that well. Just am not going to do it. So what we're going to do is I'm going to show you a different way of performing the same amount of stuff with much fewer lines of code, because I just can't. I can't write that many lines. Just can't. Won't, can't, don't care to. So I'm going to get a nifty little thing called a for next loop. I don't know if they actually still use the term next, because in C you certainly don't have to use the next. You just call it for. Back in the old days, in the 80s computer, Commodore 64 and Apple II and all that, and QBasic and all, you said for, and you gave the stuff like we've done here, and then when you wanted your next X, you'd just say next X. But anyways, in C you don't have to do that. In C you have for, and you call out yourself an integer of index. Index is a neat thing to use as an index because he's index. Anyways, we're going to make him equal to 0. And then we're going to have a qualifier. The qualifier is that index shall be less than 4. Because obviously we don't want to go through there. We have arrays 0 through 3, which is 4 of them, because 0 is actually the first one. We don't ever want to be equal to 4, because then we'll be writing to something that doesn't exist. Anyways, and then we have index that goes plus plus, and index plus plus in C just simply indexes index. Of course, if it was minus minus, it would index it the other way. A little bit beyond of what we're doing now, but it's just a fact that it does. And then I'm going to grab all these lines, these shutdown lines, all these 4 shutdown lines. I'm going to rewrite them just like this. Boom, Control V. LC shutdown of index is false. Now in the old code, there's the old code. It says LC shutdown 0, 1, 2, and 3. Well, every time this loop loops through, index is going to index. And so we're going to start off with 0 and we're going to go all the way to 3 and shut them all down false. Anyways, and we're going to do the same thing with the other little blurbs of code. With the set intensity and the clear display. And that takes, why did you do that? That was not what I wanted to do. Oh, there he is. Make me feel like I can't even operate my own computer. Happens sometimes. So anyways, that takes all these lines of code in the setup and reduces them down to that. Just by having a for next loop. Really, really handy piece of code to have is a for next loop. You can make a for next loop, pop, 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 and get lots of stuff done. And throughout this coding, we'll be using it over and over and over again. Since index, the integer of index, is inside of his little loop there, he's a disposable variable. We're only going to use him while we're in the loop. And if we want to come down the code somewhere else and have another for next loop that has index in it, by golly, we can. We just declare the integer of index and go, go, go. And he's reusable, recyclable. He's not global. Doesn't cost us anything in our program space, really, because he's not persistent. Just a wonderful way of doing things. Alrighty. So now, what was we doing? Oh, we were going to try and actually control some segments on this board. That was the whole purpose of this. I'm going to come over here, Control C, and get us a little bit of code and put it right here, Control V. Oop, I got a little bit too much. I got two of them. How did I get two of them? I don't want those two. Well, those two will do. Sure. Why not? Because one of them is a minus and the other one's a plus. So now we have this thing for LC. LC is the name. Up here we take LED control and make LC equal to it. LC is just a simple substitution. If we didn't want to do this, we could just truncate this line and say LED control 12, 10, 11, 4, and then down here instead of saying LC set row, we'd say LED control set row. So the LC is just a substitution for LED control. Anyhow, I'm wandering. Anyhow, this LC set row to row 2. All right, and if we look at our board, we've got all these 7 segments. These ones up here and these 4 here, these 2 on top and these 2 and these 2 is actually a display. It's actually one Maxim chip running those. And this here is for the program number that's going to be running. And this is the verb, and these are going to be the noun. And they'll never be negative. They'll always be positive. And anyways, so I want to work our brand new, fresh out of the oven, fresh off the printer, custom made plus minus segments. And these 2 LC set rows, so we have row 2 and row 3. So it's going to end up being this row and that row that's going to work, because this stuff up here is 0, this one's 1, this one is 2, and this one is 3. So we're going to make this one a minus and this one a plus. And so it's 2. The digit is 0. The plus and minus over here is the 0 digit, and then this would be the 1 digit, and the 2 digit, and the 3 digit, and the 4 digit, and the 5 digit. So there's 6 digits. It just happens that digit 0 is a plus or a minus. Alrighty, so I'm going to check this stuff here to see if it compiles. And we're going to tell him that he can go ahead and save it, even though I don't really want him to. And by golly, it compiles. How in the world did I ever get so lucky that it would compile? And I'm going to plug in the Arduino on the back of it, just like that. You'll see it's a Virgin Arduino. It's blink and blink. And then I'm going to give him this little bit of code here, like that. And you should see a plus and a minus turn on. Bloop, and there it is, the minus and the plus. Pretty neat. And of course, if we change that to a 3 and down arrow that to a 2, and then we reload this code, they'll swap places. See there? That is how we write to these individual digits. And we just as well go ahead and write to the first digit as well. Why not? And now we'll activate all three of the plus minus segments. 2 pluses and a minus, just like that. And then you can all see how that works. The binary number is representative of the LEDs that are on. You'll notice that the minus, and actually let's change this because this here be confusing at the moment, because it makes the minus in the wrong place. All right, this way it's not as confusing to look at. Doop 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 doop. I'll hide behind my board. Did it take? Why, yes, it did. All right, so now the minus is in the middle, and you'll notice that the minus has 2 bits that are positive. That's because there's 2 actual circuits in the minus, so it has 2 LEDs in it, so it's brighter. And the plus each has 1 LED in it. The top and the bottom of the plus do. So you'll notice that there's 4 binary bits that are on in this byte. And basically it sends a byte to the device, and that byte of information determines whether or not the LEDs in the array are on. Now we're going to go get the other little function of this library that we use to send stuff to it, and bring it over here like that in our first row that's positive, and we're going to send this to it, and this is going to send to row 1, digit 2, the number 1, and the number 1 here is actually the decimal point, and I don't want the decimal point on, so I'm going to change it to a 0. Like that, and then I'll turn this on like this by sending it the code, and you'll see a number 1 appear. Uh-oh. Something unexpected happened. Oh, we went 1 too many digits over. So let's change this 2 to a 1, and then it'll put it right by the plus. Maybe, if we're lucky. And it did. So you can see that by changing this to a 4 and sending it, it'll move it further that way. See there? So we can control with this LC set digit exactly what digit is being accessed, and we can even tell it what to send by this right here. We can change this to a 7 now, and it will send the number 7 to the digit. Just like that. And of course, this last argument here is the decimal point, and we can say true, and it will turn on the decimal point. Decimal point's on. We can say false and send it as false, and it'll turn the decimal point off. Or we can say a number 1, which is Boolean for true, and it'll turn it back on. And we can give them a 0 instead of false, and it'll turn it right back off. So there's a couple different ways that we're going to write to these. However, in DSKY, I don't think we'll ever use the decimal points. Probably not. But we will use these pluses and minuses quite a bit. Anyways, so that's how the actual library is controlled to send stuff to the digits, to operate the pluses and the minuses, and the actual 7 segments themselves to put the numbers on. Anyways, I hope that you've enjoyed this installment, and I'm basically going to turn in for tonight. Tomorrow we'll pick up and we'll actually start working on reading the IMU and then parsing the numbers from the IMU and putting them in and formatting them and actually getting some loops going that actually send the numbers right there and display them on the display. All right, until next time, this is KM4YWT. Yep, KM4YWT. Going clear.